Okay, here we go on question number 10 on the 2018 WJC additional maths paper. And the first part of this is a differentiation question. We want to find 2y by dx squared when y is 2x to the 16. So just a reminder that if we had y equals some number times x to the power of another number, then dy by dx will be a, that number, multiplied by the derivative of x to the n, which is nx to the n minus 1. So you bring the power out in front and drop the power by 1. So if I have that y is 2x to the 16, then dy by dx is going to be 2 lots of the derivative of x to the 16, which is 16x to the 15, or 32x to the 15. And then my second derivative, I'm going to differentiate this again. So I'm differentiating this time. So this will give me 32 lots of 15x to the 14. So let's just do 32 times 15 on my calculator, which is 480. So I have 480x to the 14. And that's my second derivative. Okay, part B is a problem style question. Given the following facts, find the values of a, b, c, and d. So we've got 4 things to find. So I know y is some number of x cubed plus some number of x squared plus some number of x plus a constant. I also know that the gradient dy by dx is 12x squared plus 4x plus 1. And that's my final piece of information, that when x is 1, y is 10. So I can't really start on this one because I don't know a, b, c, or d. So I'm going to start with dy by dx. And what I can do is, if I integrate dy by dx, integrating will take me back to that line. So if I integrate 12x squared plus 4x plus 1 with respect to x, then I get, let me just make a bit more room, take it over there. So it's going to be 12 lots of the integral of x squared, which is going to be x cubed over 3, or a third x cubed. If you'd rather write x cubed over 3, that's fine, no problem at all. It's just I prefer to write it as a fraction. Plus, I get 4 lots of x will integrate to a half x squared. Again, if you'd rather x squared over 2, absolutely fine. And then plus 1 goes to plus x. And then I have my constant of integration, this plus c. So if I tidy this up, I get 12 times a third is 4x cubed, plus 4 times a half is 2x squared, plus x, plus this constant of integration. Now, if I have a look at what we've got ax cubed. So I've got that now. So I've got that a is 4. So I can use that. So my a is 4. Then I got plus bx squared. Well, I got plus 2. So that works as well. So my b is now 2. Similarly, with this plus c, I have plus 1x. So that's plus 1. And then I have this constant at the end, the plus d, which I've got written as plus c. Just because of the way I've done it. So I'm just going to change it so it's back into a d, so it's in the format that we want. Okay, so now I have 3 of the 4. Now I can use my last piece of information, which tells me that when x is 1, y is 10, because this is now an expression for y. Because if I integrate dy by dx, I get y. So I can say that when x is 1 and y is 10, I get 10 equals, I'll put it in brackets because it's a substitution, 4 lots of 1 cubed plus 2 lots of 1 squared plus 1 plus this d, which is the only thing I don't know. So that becomes 10 equals 4 plus 2 plus 1 plus d And if I take off, so altogether I got 7 on this side. If I take 7 off both sides, I get 3 is my D that I want. So I can fill this in now at the bottom. My A is 4, my B is 2, my C is 1, and D is 3.